Let's see. What frequency? Okay, we're on 2.4. So we will actually get a good signal down here. So, yeah. It'd be interesting if anyone joins us at 1 in the morning, but then again, you never know.
Well, 1 o'clock in the morning here, but it's daytime in the other side of the world.
Yeah, I suppose most of my viewers are in the United States. But you never know.
Yeah, these are weird times.
Certainly is. So, while we are getting things set up, let's do a little bit of investigating here as to why the 3D printer has not printed.
Yep.
We're printing some link logs here, and at some point it stopped. Now, it didn't stop, it clogged. So the question is, why did it clog? We had this problem the last time we tried printing, but we have printed quite a few of these Lincoln logs. So we can indeed make a print work. That being said, this one certainly had some issues. Now we changed the nozzle out.
You want to hand me the plate?
We changed the nozzle from our generic M2 to the Micro Swiss M2, and it was going good for a little bit. But then, as you can see here, we have some problems. So we're going to get this off. If you want to take these, unfortunately, they're not going to be useful to us. And it's unfortunate because this is wood filament, so it's technically a mild exotic filament. Not like the most exotic thing in the world. It's Hatchbox PLA with wood pulp, essentially, inside of there. So,
It's about $30 a pop.
$30 a kilogram. It's not bad for wood filament. And honestly, we haven't had much problems with any Hatchbox filament, for that matter. There was one roll I had out of the many, many dozens of rolls that I've used over the past year or two that was a little wet, but I returned that and got a replacement, and it was fine.
Yeah, we've probably gone through, what, 800 kilograms of this so far?
No, not 800 kilograms.
Jeez. 800 grams.
Well, that's not even a kilogram. Well, you're talking about the wood stuff?
Yeah.
Oh, the wood stuff, yeah, probably around 800 grams.
Wow, I can't believe I just said kilograms.
That would be a lot of friggin' filament, to tell you what. So, we're investigating the problems as to why we had a clog. Well, I'm pretty sure it's due to heat creep, and I'll explain why. So, we're going to get the camera over here. We're going to zoom in. Now, the first thing I would check with a clog is... Well, actually, we're going to rotate my tripod here so I can move things up and down. So, get that out of the way. The first thing I would inspect on a Micro Swiss heatsink is the heat break and the block. Because if, for whatever reason, the heat break wasn't on properly on the block, filament would ooze out from in between where the nozzle butts up against the heat break, and filament would come out through the top, and there would be a bunch of goo up on the block. But we don't have that problem. So the area to check would be underneath the nozzle and look for the same thing. Well, we don't see any filament underneath the nozzle. So we know it wasn't an issue where filament was getting stuck in the heat block, or at least it shouldn't be, because filament had a clear path to go through. Now then, let's get this camera to focus a little bit. You know, they force you to use, YouTube forces you to use their app. Mm-hmm. It doesn't really play very well. So, when we're at this point now, we have to assume the clog happened due to something else. It's amazing how this almost focuses. There we go. So if it's not happening here at the block, and we're sure that heat is consistent, which we could check on our Octoprint, and I'm pretty sure heat is consistent. We're well within the melting point of this particular wood filament. The next thing we got to assume is the clog happened somewhere else, which very, very confident that the clog happened inside of the heat sink. Now, what's supposed to happen is that heat break is made out of titanium, TC4 grade 5 titanium, which is really good at not conducting heat, and that's what you want a heat break for. It breaks the chain of heat. And the heat sink has this fan here that cools it off, so that way the filament in the heatsink doesn't get melted, because you only want that to happen in the melt zone, which is very specifically right at the nozzle. So, what we think happened is this fan, which really only uses friction on the duct to hold it in place, was sitting like this. Now, from the front, I can't really see what I'm talking about, but if you look down, you would notice that the heat, this fan is not on the heat sink very well when it's like this. You want it firmly planted in place. But as this moves back and forth across the gantry, this fan came loose. And when it came loose, the air is no longer blowing straightly through the duct. It's coming out of all different sides, and it's not focusing the air to cool off the heat sink. And because of that, we get a phenomenon known as heat creep. Heat creep is when you have heat creeping up from below to an area where it's not supposed to be. In this case, the heat sink. Now, because of that, we've got some plastic in here, almost assuredly, that is stuck. And that's no good. So the first thing we got to do is disassemble things to a point to where we can get that plastic out of there. So we want to get the wood filaments out of the system. So despite the fact that it's not going to remove much by doing this, we are going to heat up the system just to its standard. Well, actually, no, we may have to heat it up a little higher than usual just to get the filament to loosen itself up.
So about 220?
No, I'm bringing it up to 260.
260? Oh.
Yeah, because we're trying to, it's already stuck in the heat block. And there is the heat break there, and it's currently, well, it was sitting at ambient temperature. So we're trying to get it to a point where it's going to melt the plastic that is not like caramelized into a spot. So we got to go a little higher than we normally would. So what we're going to do, bring it up to 260. So we're going to take this Bowden collect off as well at a certain point, because we'll need to remove the Bowden collect, or we'll need to remove the Bowden tube from the Bowden collect in order to take the Bowden tube, in order to get the plastic that is gooed up inside the heatsink out. So it's all a little bit of a process, but nothing I haven't done plenty of times before.
Do you want me to grab another Bowden collect just in case?
We will almost assuredly need another Bowden collect. That's one of the annoyances of Bowden collects, is they're really a one-time use item. Once you've used it and pulled it out, chances are the Bowden collect is going to break during extraction from the heatsink. And by heating it up nicely, we were in fact able to just pull the wood filament out. So we're going to put our filament sensor to the side, roll up the wood, and put it back on the spool. Okie doke. So we are now sitting far above what you would typically... Oh, hey, look at that. The Bowden tube actually cleanly came out. That's unusual. I wonder if our Bowden tube was ever truly firmly in there to begin with, but we might not actually break the Bowden collect. If you want to go over to the other table, get my red snips, we're going to need that. So at this point, we got our filament out, we got our Bowden tube out. So now we're going to take the nozzle off. Yeah, this is an Ender 3 Pro, and this is Really, the only stock thing left on this Ender 3 Pro is the frame.
And the screen.
Yeah, literally everything else, just put it aside now. Literally everything else is completely custom. So we're going to move the gantry up a bit because we're going to have to take the nozzle out. I didn't want a home Z, I wanted to move Z. Yep. Oh, yeah. The upgrades are never ending with Enders. You think you get to a point where you're like, okay, I think we're good now, and then you find something else that you want to do, and inevitably,
Upgrading the boat and collect.
well, we'll get to that point. We're not fully there yet. We haven't upgraded the boat and collect. The boat and collect is still there.
Well, no, to the other connection you wanted to do.
Well, it's not a boat and collect that's over there. That was a pneumatic coupler. So we're gonna zoom out, or I might not even be zoomed in here. So we're gonna put this over to the side here so we can kind of get an idea. You guys can kind of see what I'm doing here. And actually, scoot back, Mike. So we got the gantry going up, probably higher than we need to do this process.
Yeah.
But just not really. It's honestly, the higher up, the easier it is to do this.
You want me to turn on the LED?
No, it's perfect.
Oh, no, I was just looking at it as a glare on
No,
your screen, so.
it's fine. I'm going to need it to see. So we got ourselves this little screwdriver with the right size to get the nozzle. Now, here's the thing. When you're removing the nozzle on a 3D printer, you want to make sure you securely hold the block, and it obviously needs to be hot to remove the nozzle. Otherwise, with the expansion and contraction of metals, once it's cooled down after you put everything together, it contracts in place. So when you heat it up, it expands again. So in order to take the nozzle off, you want it hot, and you need a tool. But we just had some wood burn out of there. It's fun. Anywho, so the point what I'm getting at is, if you, for whatever reason, touch the heater cartridge to the thermistor while there's power on the printer, you very well could blow a component on the board, on your motherboard of the 3D printer, and absolutely just destroy it. So one little trick is to get everything up to temperature, and then once it's up to temperature, turn everything off. And then once everything's off, that way when you secure the block with a tool, there's no chance of sending electrical current from your heater cartridge into the thermistor wire, which would blow components on the motherboard. So we've got the nozzle out, and this nozzle is inside the tool here. It's currently 200 something odd degrees Celsius. So we don't just want to place it anywhere randomly. We do want to kind of hold on to it for the time being. So Mike, if you want to just hold the screwdriver, dropping the nozzle there. That nozzle will need to be cleaned out.
Will it?
Yeah, because we got caramelized gunk in there.
Ooh.
For sure.
Oh.
Yeah. So at this point, we could turn our machine back on so we can see what we're doing here. And at this point, we'll bring our attention back over to the machine at the front point of view here.
It's like a weird, like, burnt plastic, burnt wood smell.
And that's because that's exactly what it is. So at this point, we're going to remove the Bowden Collect because we want clear access to what's in the heatsink.
Did it break?
No, the Bowden Collect, because the Bowden tube came out so cleanly, the Bowden Collect did not break, which is wonderful because they almost always break when you take the Bowden Collect out of its receptacle. So,
yeah, those lights are really nice.
The light, if you're wondering, is from Gulf Coast Robotics. So you can get that from them. It plugs in line with the power supply cable.
You can easily get it on Amazon.
Yeah, they're about like $30 on Amazon. So anywho, so now that we got everything disassembled to the point that we need it, we can see our machines at like 150 degrees Celsius. But what I'm going to do is something that might make some of you cringe, but I swear to God this works. Since the nozzle's out, we have the bore of the heat sink down through the heat block here pretty much clear. So if there's anything clogging there, we can just take our little Allen wrench here, one of the smallest ones that is below 1.75 millimeters, and try and push it down. And right here I feel force and some gumminess. So we definitely have, that's all the way from here down. We have plastic that has melted inside of this heatsink, which definitely indicates that we have heat creep issues that we need to deal with, which pretty sure it's the fan duct that fell off, and because of that, no heat was being dispersed from the heatsink, so heat creeped upwards into the heatsink and melted the plastic in here where it's not supposed to melt, and that ultimately clogged the system. So we need a way to remove that heat. Now, you can do a full breakdown and then put this like in a vise and use a heat gun to melt everything out and push it out. But what we're going to do is effectively the same thing. We are going to intentionally cause heat creep to fix this. So we're going to bring our temperature back up to 260. That's as high as this machine's going to go. That's about as high as this thermistor is going to read properly anyway. So what we're going to do is, by letting this sit without a fan on the heatsink at 260 degrees Celsius, which is above the melting temperature of this plastic, we are going to let heat creep up. And we're only going to let it get to a point where the plastic becomes malleable so that it'll come off of the surface of the internal or of the inside diameter, or the inside diameter of these the bore that goes straight through everything here. So this will take a few minutes to do, at the very least. Yeah, Gulf Coast Robotics. They are the ones that that make the light. Gulf Coast Robotics doesn't really make anything. They're more of a importer and reseller. So Gulf Coast tends to find stuff that's relatively decent, available like AliExpress and stuff like that, and they'll import it to the United States and they'll sell it at a slightly higher markup. And that way you get your products faster because they're not waiting like 2 months from AliExpress, but you do pay a price premium for it being in your country. So you get it in a reasonable amount of time. So because the heat break is titanium, and because titanium doesn't conduct heat very well, it's going to take a little bit of time. Mike, do we have our heat gun down here, or our temperature gun down here? Do you see it over there?
I didn't look, but
Go take a look for me.
I pulled that up for you.
That's fine. Yeah, go take a look for me. We don't need to read the temperature because we can just kind of feel it as we wait with our Allen wrench.
Gun? No.
No, not the heat gun, the temperature gun.
Oh, temperature, yeah.
Yeah, we're going to try reading the temperatures and seeing.
You want to set for Fahrenheit or?
Well, no,
Celsius?
of course not Fahrenheit, but we'll take care of it. So, reading everything here. Let's see if I can get this in camera. So I got the laser on so you can see where I'm pointing. If I can see where I'm pointing here. Perhaps this thing's not as accurate as it would lead you to believe in terms of where you're pointing. It also doesn't help that these things don't work particularly well on a shiny surface. Yeah, because it's a reflective surface, it's not going to read the temperature properly. Oh well, so we're just going to feel it out. So you'll be able to push the filament out, and we're already starting to get some give here. As you can see, I'm pushing down.
And all the smoke.
Yeah, it looks like your hot end's taking a dump. Like, that's literally what it looks like. And we're going to take that now covered Allen wrench and we're going to peel off the gunk with our little clips here. And we're going to pull this out. Yeah, we're getting smoke. That's the fun of exotic materials, is when it's not just plastic. It's gonna burn, it's gonna make smoke, and depending on what it is, it's not gonna catch fire. It's gonna have to comply with what a thermoplastic can do. But
Oh, I did want to work with exotic materials.
yeah, and honestly, this shouldn't really happen all that much. It's just because we had heat creep, and that was not a problem of the filament.
Just this clone.
What? No, it has nothing to do with the clone.
No.
It had to do with the fan. Could I show any of my prints from my printer? Sure. We can do that. Just give me a minute here to clean off this piece right here. If we had something with a slightly bigger bore or diameter than this.
You want me to go grab the drill bit set?
Actually, yeah. Why don't you go grab the drill bit set?
Is your toolbox unlocked?
I don't know.
If not, your dad has drill bits set.
Yeah. Anywho, while he go gets the drill bits, I'm gonna show you what we were printing. We're printing Lincoln logs with wood PLA from Hatchbox. So this is real wood that we're printing. It's basically PLA mixed with wood pulp. And it was going pretty good, but we encountered heat creep, which caused the print to fail at a certain point. So we're just clearing out the clog. And we're gonna another go. It's not a fault of the filament. It's not a fault of the hot end. It's a fault of the fan duct falling off and not cooling everything down properly. So I've got my friend going to grab something with a more specific bore diameter so we can shove it through this heat sink while it's hot to get the melted plastic that got stuck in there out.
Hey, keys.
Keys. All right. Here we go. So, in the meantime, where did I put it? You know what's amazing is you have a tool 1 second, you put it down, and then a minute later you're wondering where the heck did a tool go. I find myself doing that constantly. There it is. I find myself doing that all the time. So we're just going to continue to kind of shove plastic out of here. We may have, we're going to need something with a diameter just a little bigger than this Allen wrench. So I've got some drill bits, which, you'll score the diameter of the bore that goes through this entire heatsink a little bit, but not to a point where it's going to ultimately affect anything. So I've had to do this a few times with different types of clogs, and even on my genuine micro Swiss, I haven't noticed an issue that results from any of that. So, all right, we got the drill bits. So if you want to bring it over here and just, we'll put the drill bits in here. And we'll find a size that works.
I made sure I grabbed the one that had all the small ones.
Yeah. Start with this one and kind of work our way down. Yeah, it's too big.
A little chilly out there.
Yeah, I mean, it is the middle of December. Yeah, I hate this drill bit case. It's such a terrible.
Pretty strong stuff considering PLA. That's what he just said.
Yeah, well, it's PLA mixed with wood, but I wouldn't consider this stuff strong. Oh, you print with clay paste. That's interesting. There's so many fun exotic filaments out there. No, it was a little too big as well. Keep going down until we get about the right size. Okay, that's going through. Pushing the goo out. You may have to pull it through. We'll just take this. Pull this bit through, kind of like a cleaning rod.
Smoking.
Funny. All right, cool. So
Come on, classic, The Mask.
It's such an old movie.
It's a classic.
I don't know if I would call it a classic.
It was one of my favorite movies while growing up.
Yeah, that bit was about the smallest that we're going to fit in there that's going to fit the bore. So we'll run this through another time. It's a shame this bit's so tall or short. But, you know, it's a small bit. What do you expect? Gotta clean the bit off a little bit of the gunk, because I don't want to put gunk back in. You want to pull the cleaner filament out for me?
Yeah. You said the max on this printer right now is 260 with the thermocouple?
It's not using a thermocouple. It's using the cartridge type thermistor. We didn't set the firmware to accept anything higher than that at the moment, because we don't actually have any need to go any higher than that with anything that we currently print.
ABS?
So, no, it's not ABS.
No.
Some people think it's nylon, but
No. I'm saying, like, what temperature do we have to run ABS again at?
oh, ABS doesn't need anything more than 250. Okay, so our cleaner filament, which is from eSun, which I actually like cleaner filament. I know people are confused as to what cleaner filament it actually is, and no one really seems to know what it is, but I can say that I've used cleaner filament a number of times with actually pretty good success in getting rid of gunk. So this cleaner filament doesn't seem to have any problems going through, although granted the cleaner filament's diameter is in fact slightly smaller than 1.75.
Is it?
Yeah, for whatever reason, this particular cleaner filament has a slightly smaller diameter than you would imagine.
Huh.
So,
Doesn't look like it.
well, no, it's only fractions of a millimeter different, but I measured with my calipers.
Oh.
It's only like less than it's only like 5/100ths of a millimeter smaller, but that, of course, can in fact make a difference in the grand scheme of things.
Yeah. Although, the next printer I'm going to buy, we're going to have a lot of fun with that one.
Now, the next printer you buy is probably going to be something we're going to just do really stupid stuff with.
Ender 5?
Well, you know, it's never just going to be just an Ender 5 by the time we're done with it.
Rails and all axes.
Yeah. It's funny you should say green screen, because we actually do have like a small studio over there with. I could grab the green screen and put it on there, but this is the printing area. It's going to be a little messy just due to the nature of what we're doing. All right, so that clog is definitely gone. So we're just going to see if we can't. Well, what we're going to do is we're going to cool this down for now. So we'll go down to cool down, and we're going to bring the temperature back down, and we're going to try and run just some filament through it once it's cooled down, so that way we can confirm that the bore that goes through everything is in fact clear. We don't want it hot, because otherwise it'll just melt the plastic. So all I'll cool everything down real quick, and then after that we gotta check the nozzle, see what we're gonna do about that, because I'm sure this has got caramelized crap in here. We'll probably do some cold pulls with the cleaner filament, see if we can't get a negative of the internal bore of the nozzle. So we're gonna do some cold pulls, which, you know, I've had some pretty good. When it comes to cold pulls, the cleaner filament does an excellent job.
Too bad we couldn't get that Chimera to work with this setup.
Oh well. I mean, at this point, Triangle Labs has a knockoff Chimera that I'm honestly curious about, although the Ender 5 we're definitely going to run.
How much is it?
I don't even think it's $100 for the entire thing. So, gotta grab the nozzle out of this tool here. All right, let's see, we're at 150 degrees Celsius. That won't burn me, right? Da, 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 da. If we're quick enough and gentle enough, then you can screw a nozzle in almost at temperature without absolutely burning the crap out of yourself. We're just going to get it gently snug, because now that, oh, I guess we didn't really run any filament through while it's cold to confirm the bore. Well, we're going to be doing cold pulls anyway with a cleaner filament. The cleaner filament went through, so I'm actually pretty comfortable with it. So we need to get this back up to temperature so that we can tighten down the nozzle. So bring it back up to 260. And then we'll tighten down the nozzle while it's hot. And then we're going to do some cold pulls, see if we can't fix this issue. So, yeah, Ender 3s, I think, are the best platform to build pretty much anything you want out of it. But that being said, there are limitations to the Cartesian design.
Yeah. Like I was joking around when we finished building this. When we got all the rails on it, called the Executive Edition.
I came up with that name, not you.
Did you? Was it you?
I call this one with all the generic parts, the Ender 3 Executive, and the one with my machine over here, which has all genuine parts except for the BMG. I call that the Ender Chairman, because why not? It's already my machine. $200 machine's now $1,000 machine. So I mean, might as well roll with the name. All right, so now we're up to temperature according to the thermistor, and we're going to turn the machine off so that way I don't accidentally touch the heater cartridge to the thermistor, and we're just going to tighten this down a little bit snug. The recommended torque according to Micro Swiss is 3 Newton meters, which if you don't have a torque wrench, it's really not too much past snug, but depends on your personal feel with your fingers if you can really get it to that point.
I forget, what was the Newton meters for?
My Threadripper tool was 1.5 Newton meters, so a little low compared to. I personally think 1.5 Newton meters is probably fine, but Micro Swiss, I actually contacted them, and they said their torque spec to the nozzle to their aluminum block is in fact 3 Newton meters.
Well, they should come out with a.
You can buy the same style torque wrench on Amazon at 3 Newton meters.
Oh, can you?
Yeah, you can do that. I haven't done it because they use those in like RC cars.
Really?
Yeah, they use small torque wrenches like that in RC cars, and there's varieties of like 1, 2, 3, 4, 5 Newton meters to torque everything down, because a little nitro car is still an internal combustion engine.
Oh yeah.
So you still want to get everything torqued down right. All right, so now that the nozzle is in there, we are going to take our cleaner filament and do a few cold pulls, which means we got to heat this back up. Nozzle.
I had a coworker. He was really big into the RC cars, and he actually used to build one for racing.
It's kind of neat. We're going to motion, move axis Z. We're going to move this down a little bit.
But he was more well known for painting them.
What's my dream printer if I had infinite money? Ooh, that's a good question. My dream printer would probably be some sort of metal printer. Actually, my car mechanic that I go to, he has 3D printers like this for plastic, but he's also got metal 3D printers. He's got CNC machines. He's got like all the woodworking kind of machines you could want. Guy's an absolute legend.
But if I could, some giant ass printer.
You can always get the 3D printers that print houses.
You know, for me, that I want to buy an empty plot of land anyways, eventually. And that would probably be perfect.
So we are pushing the filament, this cleaner filament in here. And you can see we're not getting through the nozzle. And that's because the nozzle is absolutely caked with that wood filament. So we were at 260, and we're going to let this cleaner filament sit in here for a few minutes at temperature, and it's going to melt itself all over that caramelized plastic, and then we're going to let it cool down. And once that happens, we're going to do a cold pull at around like 150 degrees Celsius, and that should help us get on our way. And we're going to do a number of cold pulls. So we're going to let this sit here. I actually got to go upstairs for a minute.
Okay.
So, Mike, after about 5 minutes, actually no, give it a minute, like 60 seconds or so, and then go to cool down mode.
Okay.
And just leave it and cool down.
All right. Well, you guys are stuck with me for a couple minutes. I'll probably give it another minute more than what he said. Me personally, though. So how's everyone's night going? Can you hear me all right, or should I speak louder? All right, dropping the temperature now. This mount he made originally, he has an PETG, I think. Because at one point I bought white PETG when at the beginning of the pandemic, we were making a bunch of face shields. but I want to remake this out of ABS. Uh, 160. There's 150. Oh. There's a little nasty. Up to the last like 600 grams of it, we never had a single problem with it. It's just recently with starting to use it a little bit more often because I was making all these Lincoln Logs as a Christmas present. And I decided, since the wood PLA was just sitting... All right. The wood PLA I literally had sitting for a while. Oh, fun. Finals are also fun. But I've literally been having this plastic sitting around for a while, and I wanted to make a gift out of it. And when my friend said she wanted to buy Lincoln Logs for her son, well, I said for her to save the money, and I'll make it.
I have returned. Oh, did it just fall out?
Huh? No, I just pulled it out.
You're supposed to wait for me.
Well, it was already 150.
You don't pull it out when it goes down to 150. That would have cool. Killing me. Let's try this again. Well, to be fair, we did pull some gunk out. But we're going to do this again here. So.
Oh, I thought you said pull at 150.
No. My friend here is still learning the ropes here in terms of 3D printing. So we're going to do this again the way it should be done.
I may have the money for the hobby. It's just I don't have the knowledge yet.
Well, we're getting there. Every little bit we get is a step closer. Honestly, 3D printing is a lot of trial and error. Especially when you first start, there's a lot of error. At a certain point, you start to get a second sense as to what's going on. And you honestly find that a lot of solutions for 3D printing come from industries that have nothing to do with printing. If you go far back enough, you'll find the origins of why we use 1.75 millimeter filament come from weed whacker line. Is because believe it or not, that's kind of what the precursor to 3D printing filament was people extruding weed whacker line. Now, I wouldn't recommend doing that in a non-ventilated space because the chemicals that come from that stuff can very much be harmful to you when you burn it and extrude it. But you can, in fact, print weed whacker line because they come something like 1.6 millimeters. So that's very close to the 1.75 that was ultimately
They also have
used.
1.8.
So we're going to get our cleaner filament.
But they're mostly around like 3 millimeter mark though.
Well, we do have 3 millimeter printers that are out there as well, although they have lost favorability to the 1.75 size. So now that we've got some plastic in there at temperature, we're going to let it kind of melt because we want this cleaner filament to coat whatever plastic it's touching. So we're going to wait just a few seconds.
One thing I do hope we accomplish by the end of next year: print and peak.
Ooh, if you want to print and peak, you have a tall order ahead of you because peak is a genuine engineering material, and there's a reason why it's so obscenely expensive. Well, let me rephrase that. It's not obscene if you're doing genuine R&D and you work for a big company, because at that point it's actually cheaper than going other routes. But for the average hobbyist or even small professional, it is cost prohibitive. Let's put it like that. So now we're going to go and cool down.
I just want to buy like a small roll of it, say like 500 grams.
Well, even 500 grams is more than what they usually come in. A lot of times they sell them in 100-gram spools because 100 grams will probably set you back $100 for peak. Could be wrong, but I think peak is what NASA uses, because I know NASA on the space station, they do have a 3D printer. So that way, if they need anything, obviously shipping something up to the ISS is astronomically expensive. So if you can just ship the materials and make whatever you need up there, that's, well, a game changer.
Well, 500 grams is about $300 and $13 shipping.
Yeah, that's still really expensive.
But maybe not peak then by the end of next year. Maybe the year afterwards. Yeah. Or just wait till after I buy a house.
Yeah. Well, you never know. There might come a time when peak becomes less expensive. Another really hard one to print is PEI.
And that's another thing I have.
Because we print on PEI, but you can print PEI itself. Both of those, peak and PEI, require extremely high temperatures. We're talking, I believe, somewhere in the neighborhood of around 400 degrees Celsius. So it's one of those ones where you have to water cool the stepper motors, and you have to have a very, very tightly enclosed enclosure, something that's actually going to hold that heat.
And we already had the Chimera for that, so.
Yeah, the Chimera, in theory, can do it because of the J-head heat block. But the problem with the Chimera is how the Chimera has known to have heat creep because the direct drive system is so tightly integrated into itself. So the printing peak on a Chimera, I've never seen anyone do it. It's probably possible, but not without some really good cooling. You may end up having to water cool the Chimera just to make sure that you don't have heat creep. Because God forbid you have a clog with peak, because you might as well throw the extruder portion out. You might as well throw the whole thing out, because I don't know if you could ever get the gears clean again at that point.
Maybe a Chimera clone.
Well, I mean, I'm really curious. Okay, what is peak? Peak is actually spelled PEEK.
And it's one of the most expensive filaments you can get for the 3D printer.
Yeah. So I don't know what the actual chemical name for peak is. I just know that that's the shortened word that is used for it. So, but it's a genuine engineering filament, and I mean, you can get it. It's just
PEEK stands for polyether ether ketone.
Let's see. PEEK stands for, let's see, where does it say? Polyether ether ketone. So it's
semi-crystalline thermoplastic.
It's really interesting stuff. I'm pretty sure Teaching Tech has printed a few things in PEEK because his engineering students were building an F1 car, not a real one, but like a little miniature F1 car for some sort of engineering competition, kind of like what did the Boy Scouts used to have with the wooden cars? What was that called?
Soapbox.
Soapbox Derby, yeah, kind of like that, but on steroids, so to speak.
Here's the website. It's 3D tech, but
Well, we don't have any personal recommendations.
$200 instead of $300.
Yeah, we don't have any personal recommendations on Peak because we've never used it. Of the materials we have used, my favorite brands so far definitely are Hatchbox and what's the other brand we use?
Oh,
Overture.
yeah, Overture.
Hatchbox and Overture. Okay, so we're cooled down pretty well here. So if we pull on this, it's stuck in there, which is what we want. So what we're gonna do is we're gonna back this up here, right? And hopefully everyone can get a good clear idea of what's going on. So a cold pull isn't actually pulling everything when it's completely cold. It's called a cold pull because we're pulling stuff out at a colder temperature than you would use to extrude it. So this ESON cleaner filament is really weird in the sense that it can melt and extrude as low as like 200 degrees, but have the exact same extruding properties at like 300, which is just bizarre. A lot of filaments just don't work like that. I'm going to wrap my finger around here, and we are not going to just pull it cold, like we're saying. We're going to get up to temperature. So the idea is we're at 42 degrees Celsius on the hot end right now. If I pull up, it's not coming out, right? So we're trying to pull it at the lowest temperature possible that the filament will let it release. So we're going to set the nozzle. We're going to try we'll try 120 and see if we can at least get everything to release at that temperature. So once you start getting to the temperature that you're trying to pull, you don't just yank as hard as you can. You're using a little bit of force, but not anything excessive. So we are heating up at 60, 65, 73. We're getting there.
I wasn't using too much force, but
You also didn't do it right.
well, I did it at 150.
Well, you're supposed to go from cold up to hot as you pull out,
Wow.
not from hot to cold. All right. So at around 129, it gave way. So hold on, I saw a comment here.
Interesting.
Okay. So we now have something, as you can see, a lot of gunk that came out on that cold pull. Now this is what we're aiming for, and at some point you'll pull out enough that you'll actually start getting a genuine negative of the inside of your nozzle. And we're going to keep doing this over and over again until it comes out completely clean. And this is one way to clean a nozzle after it has clogged up like crazy without doing something like an acetone bath, which acetone baths I haven't had any actual success with because I have printed
PETG.
Yeah, I've printed PETG, and PETG does not dissolve in many chemicals. The only chemicals it does dissolve in are things that are like lab grade stuff that you really don't want to be dealing with in your home.
Oh, and we also printed in T-glass.
T-glass is very similar
I think
to
that's
it's a PET something.
I can relook it up because I bought actually. We have.
Yeah, I don't like T-glass. For whatever reason, it just doesn't. It hasn't been a good experience. I don't see any benefits of T-glass over something like any other PET.
Tolman T. 3D T-glass. Well, we should end up finishing it at some point.
Yeah, maybe one day. I'm trying to do this without the camera in the way. At a point, it's taken a while to melt the plastic. Oh, there we go. All right, now we're getting some melting force on the cleaner filament. Some people think cleaner filament might be nylon. I've actually never personally worked with anything that has been officially listed as nylon, but people do use nylon for the exact same purpose we're doing right now, with pretty good results. So cleaner filament is rather expensive for the amount that you get, but the amount that you get is usually around 100 grams, and it should last an extremely long time, given the fact that you're not actually extruding with it most of the time, and you're not printing with it. So you really only use small bits of it to clean everything out. So we're just gonna let the plastic melt again all over that wood filament. And the annoying thing is, the more we bake the wood filament that is stuck in the nozzle, the harder it is to get rid of. But that is just the nature of what we're doing. So now we're going to go ahead and cool everything back down.
So they didn't have this information back when we tried printing with this before.
Mm-hmm.
But you're supposed to change the G code when working with this.
So what?
To not let the bed cool down to ambient, but down to 35 degrees to remove it.
Oh, that's interesting. Well, the tea glass is like any other PET, and that you wouldn't want to. We printed it on the sticker side, not the powder coated side of PEI. The powder coated side, we couldn't get it to stick at all, or at least not very well. And of course, when you print any sort of PET derivative on flat stickered PEI, it is going to simply bond at a near molecular level to the PEI. It's just the nature of any PET derivative, which is PET G, in my opinion. It's a fantastic material, but it is a love-hate relationship, because the properties of PET G are phenomenal. The layer adhesion is through the roof. The durability on it is incredible. The fact that it's UV resistant and chemical resistant makes it great for something you have to clean. When we were making headbands to donate to hospitals for Operation Shields Up, we specifically used PET G because that's what they asked for. And the reason they do ask for it is so that they can clean the headbands with chemicals. And if you used PLA or ABS, those chemicals would probably degrade the plastic. Where PET G, it won't do that. But the problem with PET G is because it doesn't really dissolve in anything, if it gets stuck or clogs something, your real only recourse to remove it is just brute force with heat. And at that point, you're using a torch to try and get it into where it just turns to ash, essentially, in order to remove it. And it's just a nightmare to clean and get rid of when you want to stop using it. But other than that, I absolutely adore PET G. And actually, we've got a mask over here that's I guess that's something about it failed to print. Yeah. So if we go back, let's see a little bit here. These are the headbands we printed for Operation Shields Up. And this one broke here because we print like 7 or 8 of them at a time that stack on top of each other. And when separating, I accidentally pulled a little too hard and just broke the headband there. So you can probably plastic weld it back together, but at that point, you're defeating the purpose of using PET G. But yeah, we donated about 100, just a little less than 100. But definitely around like 95 or so. So we donated to.
They're semi-cleared as well.
Well, this particular one is semi-clear because we got just natural PET and we didn't get any chemical dyes or color dyes in the plastic. But as far as what we did, we were aiming for three different hospitals, but one hospital was so well funded that it really didn't need the donations like this. Well, we found a hospital that was not well funded at all. It was in absolute desperate, dire need of them. I remember going in there and I had about, what was it, like 25, 30 masks on me, like complete shields. And I couldn't get more than like 20 feet in there before I was swarmed by the staff begging for the face shields. So I'm just like, yeah, I mean, I that's what I made them for. So yeah, go ahead, everyone take them. And at some point, I got in contact with a nurse who worked in the COVID ward of the hospital. Actually, the same hospital in the same ward where my friend passed away, or our friend passed away from COVID. So we thought it would be appropriate to make sure the safety equipment that we could provide got to that particular ward, as kind of a partly as a tribute to his life, but also to kind of help with the cause, because early in the year, man, it was absolutely insane. The supply chains have gotten much better, so we don't have to 3D print anymore, any of these, because they're finally at injection molded status. Anywho, we're back down to temperature, so we're gonna pull this, and yep, it's nice and solid. So we're gonna bring temperature back up. We're gonna go back once again to 120 was our last pull.
Was it 123?
It went a little past. It shot past because the PID is not tuned for that temperature. So I always wrap this around my finger twice so I can really grip it. And once we get close to that 120, we're going to start applying upward pressure by pulling. And we're going to see what we can't pull out this time. So we're getting about 90, 100. So we're going to start gently applying upward force. A little past. In fact, okay, so this is actually a good sign, because it pulled the other stuff out at a lower temperature because it was easier to clean. So now we're getting towards the stuff that is closer to the actual surface of the nozzle, which will require a slightly higher temperature. So we're going for 140 now. And we're going to continue applying that upward force. Let's see what temperature we actually pull out at. Giggity.
Giggity.
Okay, even at 140.
I'm actually surprised that TV show is still around.
Things have only gotten crazier, honestly. When it first started out, it was kind of like...
Even South Park.
South Park is just one of those things I don't think is ever really going to die. They adapt to the times, but...
But they're like, we've been trying to be canceled since season 1. It's like...
Ooh-wee, this is holding even at 160.
Oh, wow.
You know what? We're just going to go to 200, and we're going to keep pulling, obviously, as the temperature goes up. And whatever temperature we pull at, the temperature we start at next time.
But yeah, it's funny how...
Whew. This can definitely wear on your fingers, for sure.
But it's funny how they're still trying to push the envelope and see what...
Wow, even 200.
Really?
Yeah, even 200, it's holding. So I'm gonna give my finger a break here for a minute.
You want me to?
No. Mister, I break everything with force. This requires some actual finesse.
Hey, the people, they saw me pull it out.
Yeah, the first time because it didn't solidify. So, shoot, I guess we'll just go up to 260 and see what temperature it pulls out at. Oh,
It broke.
which is why we have this method. That is actually bizarre. Oh, I think we cut out for a second. Whew. That was getting a little dicey there for a second. Oh, Lordy. Okay. Let's take a break for a minute here. So, we focus. We can see what we have captured. We're getting closer to making that negative that we're going for. But we're not quite there. That one was getting dicey because we kept pulling and we kept breaking the filament. So that's fun. But alas, we have in fact pulled the filament out. So we're going to cut off the last bit. This stuff does stretch a little bit. Back. And we still can't extrude because we are very much still stuck in there. We're going to drop the temperature. This time, we're going to drop it to 110. We're not going to let it cool down all the way because otherwise we might not ever get it out. And we're going to put the fan back on so we don't heat creep. That's what caused all this in the first place. So we're going to let it get down. Luckily, we're using a 50-watt heater. So things heat up in a little faster than normal. Stock heater cartridge is 40 watt. For whatever reason, E3D, when you buy a Chimera, they send you a 30 watt, which is absolutely unacceptable. That is ridiculous that they would give you something so low powered.
Especially when you have the option with it to go up to a PT 100.
Yeah, you're never going to reach any temperatures that justify a PT 100 thermocouple with a 30 watt heater. Wow, I was pulling on the filament enough that I actually cut my finger.
Wow.
Oh, but yeah, a little bit of force, because if you were to just yank on that, like assuming that a certain temperature was going to be all you needed, then you would have absolutely just destroyed everything. But cooling down, getting down there. We are getting a little bit closer every time to clearing the clog. But that is kind of the nature of exotic materials, is that they don't quite behave like you would expect them with their base plastics. So at this point, I'm pretty sure it's the wood that was in the filament that is causing this clog to be so nightmarish. But
I'm wondering, could there be more wood pulp as we're getting along in this roll?
Not likely. Hatchbox is really consistent stuff usually, and I don't think it's more wood pulp. It's because the fan duct fell off, heat creep. We confirmed that the moment we took everything out, and we couldn't get our plunger past like more than a millimeter. It was a pretty heavy.
Should we put zip ties over the fan to hold it in place? Or make it out of ABS?
We could make it out of ABS, but we'd have to put the printer back in the enclosure to do that. All right, so we're down to 110. We're going to let it sit here for a second. If I pull on it, it is. Okay, so it is melted. Okay. My arms have recovered because everything is on this table. Everything is really high up compared to our normal tables, so I gotta position my arms a little higher than I'd like. So once again, we're just gonna go for. We're just gonna full send it at the temperature back up to 260 now that the plastic is melted in place. I'm gonna try just gentle consistency, because at the end of the day, once a cold pull is to a point where it's actually clean, it won't require much force at all. It does not want to yield even at 220. Just means the stuff we're pulling out is really baked in there. Hoping we don't have to torch the nozzle, but if we have to, we have to.
I think it just broke.
Yep, even at 250, the filament just broke off in the nozzle.
So time to take the nozzle off and torch.
Yeah, we're gonna have to torch the nozzle, unfortunately, at this point, because we're not gonna have anything push through the nozzle the way everything's caked in there. It doesn't mean we can't remelt this and pull it back out, though. If it even wants to melt. Of course, guiding everything down. Yeah, that's unfortunate. So, at this point, the wood plastic has won the battle, but not the war. So, we're going to turn this off, and I'm going to, since everything's already hot, I'm going to grab the block. We're going to take the nozzle out, and we're going to inspect how everything went here. Oops, it's almost out. There we go. And then we'll turn everything back on here. We could put our fan duct back in place and read our temperatures. So, let's take a look. If we can get my camera to focus, that would be splendid. Let's see.
You want me to take the cleaner film and go through and
When it's cold. So, yeah, that wood pulp in there is...
I'll make sure the cleaner filament's not inside it.
Oh, I don't think it's inside it. But once it's cold, you can push the cleaner filament through the heat sink and make sure that it is in fact
140.
Wait till it's like 40. So now this nozzle, let's see now. Gotta take our tool here and pull it out. Ooh, hot, hot, hot. Come on. It is a shame when you clog a $20 nozzle. But that being said, because it's an M2 nozzle, not a brass nozzle, blasting it with a torch to make everything inside of it just turn to ash and fall out is completely in the acceptable realm, in the realm of acceptable methodologies to cleaning this out. Now, what we can do is, before we torch it, see, I don't know if I want to acetone bath it, because we have this beautiful WS2 coating on the inside and nickel plating on the outside. And I don't know if acetone is going to compromise that coating, because those are kind of the two things that makes these micro Swiss nozzles nicer than those Chinesium ones. So let's scoot back, Mike.
What? Oh.
We're going to zoom back out. And one thing we could try, yeah, see how it's so caked on there. We couldn't even put the, where's my drill bit that I was using?
You know, I wasn't paying attention where you put it.
Why weren't you paying attention? I don't know where the little drill bit went. It's somewhere around this general area, but I do not see it. There's the magic of little tools as they get lost constantly.
Damn it, Andrew.
Don't cuss on my channel.
Hmm?
Don't cuss on my channel.
All I said was damn it.
Yeah, don't cuss.
It's right there. You covered it yourself.
Well, that's how things get lost. Mm-hmm. There's the cleaner filament. Let's see. Okay, it's finally cold enough to actually touch. Yeah, you can actually see the bore, the internal diameter of the hole for this nozzle is in fact much smaller because it is completely caked in the wood filament. Oh, I just love how this app focuses on everything but the thing you want it to focus on. There we go. See, it's absolutely caked in there. Very interesting. Check your little pokey stabby here. Ooh. Oh. Ooh. Holy cow, is that actually working? That is actually working. I wasn't expecting that. Okay. Did we just stumble upon a new method of cleaning a nozzle?
I'm glad I bought these picks.
Well, I mean, we didn't get them for this purpose, but they certainly serve. Oh, come on, focus, you cheese burrito. Been watching too much AVE. Gentle. Ah. Oh.
Is it clean?
Oh, no, it's definitely not clean, because if it was, you'd be able to see through the hole, which, granted, it is only 0.4 millimeters, but you would be able to see through it if it was clean. That being said, that is by far the most interesting clean I've ever seen. But now we can get the cleaner filament actually in. Huh. Maybe we might not have to torch this nozzle quite yet. But because now we're actually getting into the nozzle, and we're getting pretty far deep in there. Let's see. Let me hold it right there. Oh yeah, we're getting close. Oh, yeah, we're getting right up against it. I think one or two more good, clean, cold pulls. See what temperature we at, 33.
Well, let me check some thing.
I want to check the bore of the heat sink here.
Yeah.
Is our bore clogged again?
Yep.
Wonderful. So we'll have to clean that bore out again.
Actually, let me see that drill bit.
Well, you preferably want to do it while it's hot because it's solid as a rock now, but so once again, we find ourselves in a strange place. We're closer than we were before, but we are not there yet. So we're going to bring this back up to temperature. And we're going to let the heat creep up again.
Well, today is the 13th. Got 10 more days of printing available.
Yep. Well,
Maybe 11.
this is the beauty of 3D printers.
No, 10 days. Because I had to give it to.
Well, if we don't get it clogged again and we actually clean it out, then yeah, it's perfectly doable. It's not going to creep up that fast.
Well, it's at 190 right now.
Yeah, but it's got to creep up. We got to get past the titanium heat break.
Mm. Yeah, I found out her side of the family gets him the
Anywho, so
270.
yeah, it's not PID tuned for not having a fan, so it's probably not hot enough that it creeped up yet, or not long enough.
I can feel the heat.
Well, yeah, it'll take some time, but yep, there's the poo. That is the result of heat creep. Oh, goodness, this thing can't focus for anything in this app. Okay, so we need to... It focuses on your hand.
Well, I tried.
All right, I wonder if this is cold enough that I could just pull this out. All right. Yeah, zoom out here. All right, so now, here, scoop.
Whee!
Despite the fact that it is 260 degrees Celsius, I should be able to still do this by hand if I'm quick and accurate enough. Just barely in time. Ooh-wee. Yeah, if that nozzle was made out of diamond, you would burn yourself instantaneously because diamond conducts heat better than literally anything else we have.
Do they actually have diamond tip nozzles?
No, they have ruby tipped, but not diamond.
No.
Okay, so now we have to tighten this back up a little bit here. Which I'm going to do something that I've been saying not to do and hold the the block while it's on, but that should be good enough.
Well, as long as you're not hitting the sensors, it should be fine.
Well, yeah, but that's the thing, is no one ever intends to hit the sensors. It just happens.
Yeah, we've done it a few times already.
Temperature. Cool down. We're going to try another cold pull because, for whatever reason, we were able to use the pick. Try blowing the fan directly on the heat block, cool down a little faster. And you get to see all the troubleshooting I have to do on these printers in real time. Can't just sit back and watch me do this, or wait for me to do this like you usually do. These little things are pains in the asses when they fail, but they're amazing when they work. Okay, we're just getting down to temperature. Wow, this thing literally focuses on everything except what I want it to focus on. How? YouTube, you need to adjust your app for live streaming. You know, I feel like there's probably an app in the Play Store that just utilizes YouTube's information to live stream properly. Just haven't done it
Well,
yet.
I've actually, years ago, I think I was on my S7 or the Axon 7 at the time. But I was at a race, and I was live streaming the race just through the camera app to YouTube.
Just through the camera app? Well, I'm on my Axon 7.
Yeah, I was uploading live to the YouTube app from the camera app, natively on the phone.
The camera app does not have that.
So I must have been on the S7 at the time.
Yeah, because I can tell you that for certainty, my Axon 7 does not have that capability. So, okay. We are in there. All right, this one's for all the beans.
Is it?
Yeah, because if this cold pull goes awry, then we're so close to getting it undone, but yet so very far. Oops. Temperature, nozzle. Bring the temperature back up again as we pull.
What are you going back up to?
260. Because I have no idea what temperature it's actually going to pull at. We're just pulling at the lowest temperature it'll allow us to pull at. Thing is, the more you pull on it constantly, the more stress the filament gets, and that's why it broke off like that. Normally it won't do that. This filament tends to stretch a little bit. But this stuff I know for a fact will melt as low as like 180. So the fact that we have to get it up to these ridiculous temperatures to get it to melt enough to just pull out after it's already set itself in place. Well, we're getting more out. These cold pulls are, in fact, doing something.
Now, is that everything that was in there?
Well, if it was everything that was in there, we would be able to melt this filament through the nozzle.
Well, no, I'm just saying to break off inside again.
No, it pulled dirt out, which is a clear sign that it definitely pulled something out. This is what the cold pull is designed to do.
Now, with this, do you have to cut it like you usually would with filament, where you have the pointy end?
No. That's only for getting it through a lot of straight portions through this extruder into the tube. But we're not going through a Bowden tube, we're going directly into the hot end. So it's not extruding. So we're going to let it sit and melt again. Temperature. Oh, this dial. There's one thing I absolutely hate about the Ender series or Creality in general. It is their turn dial button system. It is absolutely unreliable in its consistency. Oh, man. I tell you, this clog, it's a pain in the butt. This is why people do use brass nozzles, though, because if you get a clog this bad, you just toss the nozzle. But if you have a printer that's reliable, like consistent reliability, having a good nozzle is absolutely worth the money.
I wonder if we should have used the brass nozzles for this print, though.
Well, it's not the print, it's not the filament that's the problem. It was the heat creep that was the problem. So that's why this happened at all. So we are just fixing the situation as best we can. We're seeing if we could do couple. Honestly, at this point, we really should have just torched the nozzle. I mean, the fastest thing would have been clear out the bore in the heat sink and then torch the nozzle until everything turns to dust, and then shell and then like do one cold pull and be done with it. But we're trying to see if we can do this without using a torch because we don't have a torch with us. Well, actually, no, maybe we do. We might have. I don't know where though.
I think your dad has a torch.
Well, Ben may have a torch, but I don't know where he keeps it in this basement, if that's the case. Certainly be a deviation from the norm.
Wrong torch!
Yeah, that ain't gonna work. Well, some people do actually do the same method over a candle, believe it or not.
Really?
Yeah, you just want to make sure you have the nozzle encased in some tin foil because the burnt wax will ash up the nozzle with like just black soot if you don't wrap it in tin foil first. All right, so we're back down to 108.
Well, you have candles, right?
Yeah,
Do you have tin foil?
well, it'd be better if we did it over like a stove because then you don't have the ash. But I've never personally torched a nozzle. Never personally had to torch a nozzle. So we're in there. Get a good grip on this. Going up in temperature, we're 165, 170. Yeah,
200.
we seem to have to get this up at a really high temperature. So whatever is on there is like super on there, which is unfortunate. Okay. Getting better. So look at our progress. Swear to God, camera, if you do not focus. This YouTube app is trash. So it's not completely clean, but
At this point, is it the YouTube app or is it your phone, your old phone?
it's the app.
Or both?
No, it's the app. On my camera, I never have this problem with just the camera app. It's amazing because it's pressed to focus on the screen, and it will focus everything around what I press, which is ridiculous.
Well, you've been having more and more problems with your camera, anyways.
Not really. It was more my battery was dying, and I've since replaced the battery. You know what? We're going to just keep the temperature. We're going to see if we can get it to stick at 200 instead of 110. Oh my God, I swear. I go just a few clicks and it goes from 100 straight to 260. This dial is absolutely ridiculous. I hate this dial so much. I want to use a touchscreen, but the touchscreens usually don't have all the latest Marlin information in there because you have to have like pictures like tied to what you're doing in the menu system, and they're never up to date. You can get the hybrid ones that switch back and forth between touchscreen and the dial, but none of those are supported by TH3D, which, since we're using their software, or their firmware, and their motherboard, we'd have to have like support from TH3D to do that. Kind of a bummer, especially considering that's their main argument for against using it is because the touchscreens are never up to date with Marlin. But the fact that they make hybrids now, which you can go back and forth, kind of negates that argument entirely, in my opinion. Okay, so it does in fact hold at 200, which is crazy. So then let's bring the temperature back up. Oh, okay. It popped out at a much lower temperature, which, well, considering we didn't really let it cool down to the same temperature as we've been letting it, doesn't really tell us much. Oops. This dial is an absolute nightmare.
Yeah.
I absolutely loathe this dial. You know, I wonder if I could get. Hey, look up how hot soldering irons get. We might be able to get the same temperature out of a soldering iron, depending on which ones we have. But
Yeah.
see what temperature solder melts at. Because then we could just take the nozzle and just let the soldering iron get stupidly hot and see if that doesn't do anything. I mean, it's not going to get hot as like a torch, but, you know, whatever gets us to where we need to be. Yeah. Interesting. Now, I'm curious.
185 degrees. Soldering irons are designed to reach a temperature range of 200 to 480 degrees Celsius.
Well, if we got to 480, that would definitely be probably hot enough to char everything, but I don't know if our wee little...
Cheapo Depot?
Yeah, I doubt ours gets that hot, unfortunately.
Because solder melts approximately at 185 Celsius.
So at this point, I actually want to try something.
Uh-oh.
Because it's cleaning. It's cleaning, or coming out relatively clean. So let's see, where's our good Bowden collect? You see it anywhere?
What?
The good Bowden collect? This is not the good one.
You put it over there.
Well, if you could be more specific, that'd be great.
In between these.
Oh, here it is. So, assuming there's nothing in the bore here, which might as well check, considering our luck. Yep, that's about right. I don't know if the BMG is going to play nice. It sometimes plays nice with this filament, but because this cleaner filament is not 1.75, it's just slightly under that. And then getting it fed through this thing is another matter. Gotta have these things incredibly straight to feed through these faux BMGs. It does feel like the gears are in fact gripping. Now, this BMG is going to grip harder than either of us could grip the filament.
Do you know how many watts your soldering iron is?
No clue. We'd have to look at the actual
It's
soldering.
over here, right? Or is it in the garage?
It might be in the garage because the last things we soldered were wiring for the cars.
We do have a weird range of hobbies.
Well, fixing our cars is less of a hobby and more of a necessity, but
Well, we've been upgrading headlights, and that's not really.
well, considering a lot of us drive exclusively at night, it's a worthwhile upgrade.
Sure.
I'm going to try extruding filament. I don't think we're going to, but we'll see.
But yeah, if you have a 16 to, say if you have like a 30 watt, it gets up to 430. If you have 100 watt, it will get probably 600 degrees Celsius.
All right, well, we're about to try this here.
Oh boy. Because a 100 watt soldering iron gets up to 1,000 degrees Fahrenheit.
Nah. Well, the very tiniest bit, the itty bittiest amount. Wow, I wish they would just have manual focus on this, because it's clear it wants to focus. The very tiny itty bittiest amount came out. Which is a small success. If we had those little acupuncture needles they use to clean nozzles, Be nice, but we haven't had those in
Yeah, I was
forever.
just literally looking at things for cleaning nozzles on AliExpress.
Yeah, well, we don't have 3 months to wait for AliExpress. This BMG has got this nozzle in some pretty heavy pressure.
Oh,
Yeah. Like the dual hob gear design with the 3-to-1 gear reduction to increase the torque, it puts out, you'd be surprised how much pushing force that system has. It is absolutely astonishing.
so just never put your finger next to an open set of gears by it.
Well, the never put your fingers in a set of gears in general is good advice for anyone.
Technically. Sometimes you have to put your fingers near gears.
Near, but never put it in.
Close. No.
It's so disappointing how absolutely close it is to wanting to let filament through. What an absolute travesty. Well, unfortunately, this is where we are so close yet so far. This is where I would probably call it. So the clog has won for now. But I guess next time we do something, we're going to torch the nozzle and see what we can't do with that. We came so far. We got, at the end of the day, a huge amount of gunk. Hold on, let me zoom out. All the little wood turds that were inside of this thing. I mean, each one of those was a step closer to success. Alas, sometimes it takes a little more than what you're giving it. So what we're going to do is we're going to call it. But we tried. So for those of you who joined us for this journey, thanks for dropping by. But yep, only so much you can do.